Good morning everyone. My name is Harshal Patni and I'm going to be talking about my paper on provenance aware range sensor data. This work has been done at the Noesis Research Lab, which is now designated as the Ohio Center of Excellence in Knowledge Enabled Computing. The outline of my talk, we will first have a quick look at the motivating scenario. Then using the motivating scenario, we would define the term provenance. Then we will have a detailed look on the sensor provenance management system and the workflow implementation, followed by future work and conclusion. The motivating scenario. Let's say we need to search for all sensors which have observations related to a blizzard occurring in Nevada on the 24th of August 2005 at 11 am. In order to do this, we first start with all sensors in the US. Then, taking into consideration the spatial information, which is Nevada, we filter on the spatial information to get sensors in Nevada. Next, considering the temporal information, which is 24th of August 2005 at 11 am, we filter on the temporal information to get all sensors in Nevada which were active on the 24th of August 2005 at 11 am. And then we take into consideration the thematic information, which is blizzard. Now before we look at the filtering of the thematic information, let's see what a blizzard is composed of. So a blizzard is composed of high wind speed, above 35 miles per hour, snow precipitation and low visibility, less than a quarter mile. And these conditions need to hold for at least 3 hours in order for us to say that we have a blizzard. Now once we've seen what a blizzard is composed of, the next step is to filter on the thematic information. So now the sensors that we see on the map are the sensors which are currently located in Nevada and which were active on the 24th of August 2005 at 11 am, measuring wind speed, precipitation and visibility. Now once we've seen this motivating scenario, the next step is to see what do we mean by provenance. So the location information, which is Nevada, the temporal information of the observation, which is the date and the time, and the thematic information, the attributes that were being observed, are the provenance information of the observation, which is required for sensor discovery. And provenance is the history or the lineage of the data entity. So now once we define this term provenance, let's have a detailed look on the sensor provenance management system. But before we do that, let's have a quick look at an overall architecture. So our sensor provenance management system comprises of 3 main phases. The provenance capture, which is a data capture phase, provenance representation, where we annotate this data which was captured in the provenance capture with the concepts in the sensor provenance ontology, and provenance storage, where we store this provenance aware sensor data in some sort of a data store, virtuous or RDF store in our case. Now in the next few slides, we'll look at each of these phases in detail. Provenance capture. So our world is surrounded with sensors. We have weather sensors which have weather related observation. We have camera sensors which have traffic information. We have satellite sensors that give earth related observation. Even our phones are equipped with sensors. So the main idea behind provenance capture is to collect the sensor information and the observations taken by the sensor. In other words, the sensor data. In provenance representation, the data and the observation which was collected in provenance capture is annotated using concepts in the sensor provenance ontology, making this data provenance aware. So now, before we look at the sensor provenance ontology, let's have a detailed look on the sensor ontology and the provenance upper level ontology. So the sensor ontology comprises of the following main phases. It has an observation, and this observation has a location. It has a sampling time, which is the time at which the observation was taken. It has a result, which is the float value of the observation. So in case it is a temperature, it would be something like 48 degree Fahrenheit. And it has a feature of interest, which is a blizzard or an hurricane. This observation also has an observed property, and this property is anything like temperature, wind speed. So it's a phenomenon. And this observation also has a procedure, which is a process. And this process is the sensor or the weather station, something that is observing or taking these observations. Once you've seen the sensor ontology, let's see the provenance upper level ontology. Now the provenance upper level ontology has three main concepts. It has an agent, it has a process and a data. So process models all entities which affect the data. Agent models the entities that execute the process, and data is generated by the process. This data could also have some parameters, and it has a spatial parameter which could be a location. It has a domain parameter depending on the domain in which we need to use the provenance information, and it has a temporal parameter which is the time. And it also has a data collection class which basically means collection of data. Now once we've seen the provenance upper level ontology, let's see our sensor provenance ontology. So this figure shows the provenance upper level ontology aligned with the sensor provenance ontology. What it says is now all the circles which are colored are the concepts in the provenance upper level ontology, and the concepts which are white are the concepts in the sensor ontology. So we have a concept called observation in our sensor ontology, which is a type process in the provenance upper level ontology. This observation has a location in our sensors ontology, and this location is of a type spatial parameter. This observation also has a temporal value which is time, and this time is a temporal parameter in the provenance upper level ontology. And this observation also has a parameter, and the parameter is a property, and as I said, this property could be anything domain specific. So in case of sensors, it is the phenomena we are measuring. So it could be anything like temperature, wind speed, precipitation, etc. Now the sensor ontology also has a concept called process, which I said was a sensor or a weather station, and this is of the type agent in the provenance upper level ontology. And this process is also located in a specific location. We also have a class called observation collection, and this observation collection is of the type data collection. It's a collection of observations. So once we've seen the sensor provenance ontology, the next step is to see how we do provenance storage. So in this phase, we basically store the provenance aware sensor data into a data store and make this data publicly accessible by adding it to the linked open data cloud. Now we make this data linked by linking it to geographic dataset like GeoNames. Now GeoNames contains information about countries and roughly 8 million place names. So once we've seen the sensor provenance management system on the whole, now let's see our workflow implementation. So our workflow implementation begins from the MesoS service data. The MesoS service data is a project at the University of Utah that under the Department of Meteorology that collects observations for roughly 20,000 sensors in the United States. MesoS provides an API for us to access the observations that were collected by these sensors. The next step is to convert this data to ONM. Now ONM, observational measurements, is an open geospatial consortium standard for encoding sensor descriptions and observations. And this ONM is then converted to RDF using our sensor provenance ontology. And this data is then stored into the Virtuoso RDF store, and then it is made publicly accessible on the linked open data cloud. So Virtuoso RDF store is an open source RDF triple store from OpenLink software, and it currently contains 1.7 billion triples of sensor observational data. Now future work. So in future, we are currently working on implementing the motivating scenario as shown in slide 1. We also plan on implementing the provenance query operators. We are also writing a plugin implementation that can add provenance information to any processing of sensor dataset automatically. Conclusions: we developed an ontology-driven provenance management infrastructure for sensor data called Sensor Provenance Management System, and this was developed, and we developed a domain-specific provenance ontology by extending the provenance upper level ontology. An extension of standard ontology helps sharing and integration of provenance information across different domains. Acknowledgements and questions can be asked on Skype.